We are welcome back to question 1 on solving system of differential equation. So this is what we have here. We have the s prime, x1 prime equal to x1 plus 2s2, and then we have the s2 prime equal to what? This plus this. And we have the data given, the initial condition given. We have it here. Okay? So that's the solution to this problem. Step 1, write in matrix form. Write in matrix form. And that will be equal to this one, this x1 prime, s2 prime, in column form can be written as what? As this one, x1, okay, prime. And it's a vector, don't forget it's a vector, and that will be equal to the coefficient of those x1, s2, and that will be equal to 1, 2, 3, 2. Then we're going to represent the x1, s2. Ideally it should be what? x1, s2. We want to represent x1, s2 as just a single variable. That will be equal to what? Times x times this. Okay, so this is a vector. Then we can also indicate the calculate the data given. That will be equal to this as a vector. Okay, you can see at 0 equal to matrix form 0 minus 4. So that is a matrix form. We have represented the x1, s2 by this vector. Then the next thing to do now to get the solution that we need for us to calculate the eigenvalue and eigenvector, okay, of the system. Okay, notes. To calculate the eigenvalues, we need to solve this equation. So how do you apply this? Okay, our A is what? The matrix A is 2 by 2. A is 2 by 2. 1, 2, 3, 2. That's A. Then apply this expression, this equation, to calculate the eigenvalue. Okay, the implications of that is this. It's very simple. We're having det mean determinants. This one, the shortening form for determinants. Determinant of this, and then this is your main diagonal. Okay, so your main diagonal now minus what? Eigenvalue minus eigenvalue. So I'm going to have this now here. I'm going to have here also 2 minus eigenvalue equal to what? Equal to 0. Okay. In my previous video, I found you check the channel. I've explained this. I think I made like 2-3 videos on these aspects. So this one, we have this now. So this will be this times this, and then minus this one. Minus 6 minus 3 times 2. Okay, so let's do the expansion. This one times this, that's 2. This one times this, that's this. This one times this, that's this. This one times this, that's plus r squared. Then minus 6 equal to 0. So let's arrange according to the power with this. Minus this, that's minus 3r. And then 2 minus 6, that's minus 4, equal to 0. Then we can factorize this expression. R squared, P that. Factors of 4, they can give us minus 3. That is 4 and 1. So how do we use 4 and 1 to get minus 3? To get minus 3. So that will be minus 4 plus 1. So R is equal to what? This is R minus 4 is equal to 0, or R plus 1 is equal to 0. Then, for that, R minus 4 equal to 0, we have R equal to what? 4, or R plus 1 equal to 0. So that is what r equal to what? Minus 1. So the eigenvalues are minus 1 and 4. Okay? So then the next thing to do now, we are going to calculate the eigenvector for the respective value for what? Eigenvalues. To calculate eigenvector for r equal to 4, we solve this system, which is what? R is what? 4, and that will equal to this 4i equal to 0. And I didn't even explain the meaning of this I. I is just identity matrix. And what is the meaning of this expression? I'm going to explain it straight away now. So the meaning of this expression is, come back to your matrix. That will be your main diagonal. We have already said, look at this expression here. 1 minus eigenvalue, 2 minus r. Okay, just substitute the value of r there, and that will be 1 minus 4. That's minus 3 here. Okay, followed by 2, 3, and then 2 minus 4. That's minus 2. So it's then the component of that is the meaning of this bracket. That is the meaning of these brackets. Okay? Then this one is your eigenvector. And the component of that will be u1, u2. Okay, equal to what? Equal to this one also is a vector, and that will be equal to 0 and 0. Okay? So that's that. Again, this expression a minus 4i is this. It's this, and I've explained that. And this one is the eigenvector we're looking for. Okay? Then the next thing to do now is to do augmented matrix. And that will be combination of this matrix, of this one, and the equal value. And that will be equal to what? Minus 3, 2, 3, minus 2. Then you put a line in between, and that will be 0, 0. That's your augmented matrix. Okay? So the next thing to do now is to do the row operation. Row operation. And what we want to achieve here, this is 3. This is minus 3. That means we can say row 2 is equal to row 2 plus what? Row 1. Because we want to ensure that the first element on the second row is 0. At least the first element in the second row is 0. And that will be equal to what? That will be equal to minus 3, 2, 0. Then this one plus this one, 0. This one plus this one, that's 0. Okay? So that's what we have now. Now, don't forget the first column is the coefficient of u1, the second column and the coefficient of u2. So, from row 1, that will be minus 3 times u1, this one times this one, then plus 2 times u2 equal to 0. Okay? And that means 2 u2 equal to what? 3 u1. Okay? So u1 is equal to what? 2 over 3 u2. Okay? So let's consider u2 to be this s. The eigenvector will be equal to what? u1, u2. My u1 is what? 2 over 3s. My u2 is what? Is this. You can factorize this one. You have 2 over 3 and then 1. So we take this one as 1. Therefore, this one is eigenvector corresponding to r equal to 4. Therefore, the first solution of the system is equal to x1, and that's equal to, don't forget the formula, we said what? This. So substitute that. we have this one is the first eigenvector, which is what? Which is 2 over 3, then 1, then exponential. Our R is what? 4t. So that's the first solution to the system. So then the next thing to do now is to calculate eigenvector for R equal to minus 1. Okay? And to do that, we use this what? We use this system, we use this one to get the eigenvector. And the meaning of that is that you come back here, okay, and the main diagonal, you get to subtract what? Minus 1 from that place. This is minus 1, so this will be 1 minus minus 1. So that will be equal to what? That will be 2 here, that will be 2 here, that will be 3 here, and then here, that will be 3. 2 minus minus 1, that's 3. Okay, then the complement of this will be u1 and u2 equal to what? Equal to this. Okay, then the augmented matrix, that will be 2, 2, 3, 3, then you put a line, 0, 0. So that's the augmented matrix. Then you want to also ensure that at least one of the elements in the second row is 0. So what we'll do there is row 2 is equal to 2 minus, can't you multiply this one by what? 3 over 2. So we can have 3 here. So that will be 3 over 2 times what? Times row 1. Okay? So the row 1 is not changing, it's just the reference points. Okay? And that will be equal to 3 minus this. Don't forget that 2 times 3 over 2 will give you 3 also. So this will be 0. Also, the same thing also, this also will be 0. Okay? So that's that on this. That's that on this. Then, so we now have now 2u1 plus what? 2u2 equal to 0. Therefore, 2 we cancel, so we have u1 equal to what? Minus what? Minus u2. Okay, so consider u2 to be what? To be this. So the second eigenvector will not be, this one is what? That will be minus s, and then u2 is what? Is this. And that's what? That's minus 1, 1. So we take this one as 1. Take what? Take this to be equal to 1. Then, therefore, minus 1, 1 is the eigenvector for r equal to what? R equal to minus 1. Okay? So, therefore, the second solution is equal to, the vector is what? Minus 1, 1, and then exponential, the eigenvalue is what? Is minus 1, so times t. So that's second solution. So the general solution of the system, is this one, is a function of t equal to c1 times what? The first solution, which is what? 2 over 3, 1, then plus c2 so that's the general solution of the system. Don't forget the condition given. We're given the condition 0 minus 4. Okay? So we need to find the value for what? We need to find c1 and c2, which we don't know yet. Okay? So to do that, we are going to write this equation in form of xy. Okay? So if you do that, so the general solution as a function of t will be equal to, and don't forget, we have this expression as what? 0 minus 4. Okay? The general solution. So that will be equal to what? Just substitute. This is a function of t. These are t value. This means when the first equation t is 0, then you have what? You have this. So let's substitute that. That will be c1 2 over 3. Then here also minus c2. Then the second equation c1 also c plus this is minus 1 also. Sorry, this is minus 1 plus, so this is plus. Okay, is here minus 1 plus. So that will be equal to plus what? C2. So that's what we have here now. And the meaning of this is C1 2 over 3 minus C2 is equal to what? Is equal to 0. Okay? And then C1 plus C2 is equal to minus 4. So these are the two equations. From 1, C2 is equal to what? 2 over 3 C1. Okay? So substitute that into the second equation. So you now have C1 plus C2 is what? 2 over 3 C1 equal to minus 4. And that will be equal to what? Times 3 times 3, that will be equal to 3C1 plus 2C1 equal to times 3 also minus 12. Okay, so this one plus this one, that's 5C1 equal to minus 12. So C1 is equal to what? C1 is equal to minus 12 over 5. That's for C1. C2 is equal to 2 over 3 C1. C2 will be equal to 2 over 3 times C1 is what? Minus 12 over 5. And that will be equal to C2 is equal to 3A1, 3A minus 4. So that's minus 8 over 5. That's C2. Okay, so therefore, the general solution will now become, your C1, we have it, that's minus 12 over 5, vector, 2 over 3, 1, exponential, 40, then minus C2, it's going to be plus, so plus times minus, so we have this, 8 over 5, the vector is what? Minus 1, 1, then exponential, minus t. So that's the general solution for the system, and that's that on this question. Okay, if you're new on this channel, please click on the icon on the video so that you can keep track of the updates of this channel. Okay, so click on like button and send your comments. Okay, finally, share this video on social media platform. Share the video on social media platform. Okay, join the next question. Still on what? System of differential equation. We're going to question 2. Join question 2 for system of differential equation.